In this video, let's talk about linear regression. Now, linear regression is actually a supervised learning algorithm. We studied supervised learning in some videos back. Now, let's proceed on to the next slide. This is broadly what we do with machine learning. In our school, we were given some data and we were also taught some rules and we were to solve an answer to the question. But in machine learning, what happens is we are given a data that is input and we are also given the answers, that is the output. Now it's your task to figure out the rule, that is what leads from the input to the output, the data to the output. You figure out the rule behind that. That's basically what any machine learning algorithm does. And linear regression is not an exception. Linear regression also does the same thing. That is, it from the inputs and the answers, it finds the rules behind it. Let's now talk about an example. My math score actually depends on the score in the chapter and exam, the study time I put in, the problems I solved, and the lectures I attended in school. That will depend. These are the factors behind my math score. Now let's look at some example. Person A, person B, person C, all the data are given and also the math scores are given. That is, as I told you before, all the factors are given and all the answers are given. Now you have to figure out from the factors and the answers that what is the rule behind it. That is, you have to figure out what is the importance of each of them. That is, what is the importance of score, what is the score in the chapter in exam, what is the importance of the study time, how important are the problems I solved, maybe from my book or maybe from another book, the number of lectures I attended, the importance behind it, and finally the project that I did. These you need to figure out the in linear regression. You need to figure out the importance of each of the components, and finally, after figuring out, you can predict what person D would score based on person A, B, C, based on whatever you have learned from person A, B, C. Based on that, you predict a score of D. This is the graphical representation of linear regression based on some independent variables, that is study time and lectures attended, and here it's only one factor that is considered. Maybe suppose study time. How is study time related to my math score? That is considered. And we are plotting a straight line based on that to show the relationship between the study time and the math score. On the x-axis is the study time and math score is on the y-axis. Now we are trying to figure out that straight line and the relation between the study time and the math score, and the points are actually the points of how many hours I study and what I scored in the maths exam. So I am trying to figure out a rule, that is, I am trying to figure out the straight line. If I can correctly figure out the straight line, I can be using the straight line, I can predict what others would get based on the study time. That is the main what we are trying to achieve. Now let's look at the evaluation, that is the final prediction that I make and the errors I make in the prediction, in the solution I mean. Suppose I have 4 exams given to me. After linear regression I have 4 exams given to me. In the first exam I scored 8 out of 10. In the exam 2 I scored 7 out of 10. In the exam 3 I scored 9 out of 10, and in exam 4 I scored 6 out of 10. Cost is used to denote how much I missed, that is how much is the total error. Now in exam 1 I scored 8 out of 10, that is I made 2 errors. In exam 2 I scored 7 out of 10, that is I made 3 errors. In exam 3 I scored 9 out of 10, I made 1 error, that is 6 errors so far. And in exam 4 I scored 6 errors, that is I scored 6 out of 10. So I total error is 10 out 10, that is the total cost is 10. You say the cost is 10 for the linear. After linear regression, after learning from examples, my cost is 10, that is I made 10 errors, 10 number of errors in the 4 exams that were following the linear regression. Here I am actually trying to show you what the cost is. That is, the dotted line was my prediction. Now I made an error. So that point is getting connected to the straight line, as you can see, and that the distance of that line, connecting line to the actual straight line, is my error. The connection between the point and my prediction is actually the error. Now if I can plot similar connecting lines from all the points here, then that will be the individual losses, individual errors, and totally that will be counted as cost, that will be said as cost. So cost is, as you saw earlier, cost is, say suppose you have 4, I told you that is 4 exams were given, and for each exams you made an error. A total of that error is called cost. Here also the cost is the distance of the points from the straight line, that will be the cost. And here you can see what actually cost means in graphical way in the graph. So the question arises, in the linear regression, what are we actually trying to achieve? We are trying to reduce the cost, that is, we are trying to make less errors in the prediction, in predicting. That is, for a new problem, I am trying to make less errors in the new problems, and maybe we will study it in some following videos. We will use a method called gradient descent in reducing the error that we make. A algorithm called gradient descent in the next few videos. We will use that gradient descent to minimize the errors that I am making. Thank you. That will be all for this video on linear regression. Now, as always, there will be a poll that needs to be answered within the first 7 days. The poll will take place on the channel community, that is the YouTube's channel community. and you can suggest me what next video should I make. Unless you suggest something else, I am going to go ahead with polynomial regression. This time we studied linear regression. Now let's look at polynomial regression. That's what we are going to study next. That's the end of this video. Thank you and have a nice day ahead.